Hello, good evening, everyone. So, am I audible? Can anyone just please confirm?
Yes, you're audible.
Okay, thank you, thank you. So, okay, so good evening, everyone. So today we have joined. We can wait for 1 or 2 minutes from six. Uh, we have the session, but we can wait for 1 or 2 minutes. Then we can start, so that many are joining still. So I can introduce myself. So I'm working as a PhD student here at IIT Kanpur, and mostly my work is focused in the domain of power systems with some renewable integration and to devise some uh, applications as well as to formalize some mathematical formulas to derive some mathematical formulation so as to work on the distribution system side with operation, mostly operation control in the presence of renewables. So, and this is a course where both power electronics and power systems merge, and will be trying to focus as professor is taking the course. We have gone through the video lectures, so we will have a brief summary of the entire week, and with that you can ask questions, and we have the questions from the previous you may say previous semester, I guess, or maybe previous year. So we'll solve. I also have some additional numericals so that we can solve it again if the time permits. And additionally, so this week's the entire week's assignment that is uploaded in the portal, so we can't discuss it right now, means in this week, because the date is not over yet, right? So once the due date is over, so till then you can attempt multiple times, and after that, when the due date is over, so we can discuss those questions. But till then, we will solve the questions of similar types. Maybe some of the similar types, maybe some from a bit different, but mostly will be kind of similar. But the values and numerical answers won't match. Okay. So, and feel free to ask and make it an interactive one. So, so let's begin. Okay. So first of all, as we all know, Sir has also discussed that the need of these power electronics integration in the power systems, and to improve the voltage profile and all these things. And additionally, we have the global aim of means global aim for India is to achieve 50% reduce the 50% carbon footprint by 2030, and 100% by 2070. So overall, it's so overall what we so the entire aim of integrating the mostly now we see the renewables are getting integrated day by day, right? And with that, we also have the aim of integrating the electric vehicles. But since we say that the electric vehicles are getting integrated, but the ultimate carbon footprint is not at all reduced in the percentage that we try to realize to some extent. But still, if we can move towards the full renewable side, then only can we achieve these global carbon footprint reduction and all these things, right? So the converters, the inverters that we typically use in the power systems is the means they impose further challenges, and system needs to be studied further, and for that we need to pose the solution strategies and to deliver seamless power to the customers, right? That's our ultimate aim. But with the integration of the renewables comes various challenges, because uh, they are the things with the part of, as we all know, the basic thing is that the synchronous generators do possess the behavior of system inertia, but that inertia is missing in the renewable side, as the power electronics based devices. But in the so first of all, I'm trying to give an overview why the power electronic applications, the necessity of power electronics, the need of power electronics applications in power systems. And one of those applications that we have started, Mr. has started in this week, is the reactive power compensation, and to improve the voltage profile so as to minimize the means to have a better voltage profile at the receiving end, means to reduce the voltage regulation, and with that we can uh, get a good amount of means the voltage profile should be. Yes. Yes. Okay, so a brief of the power system scenario at a glance, and some of these is, I have taken in the last course on operation and planning of power distribution systems. So you may find some things quite similar with the initial slides, but later on these things will be entirely different. To give a brief overview, I've taken these images from there itself. Right? So the power systems, uh, as we all know that nowadays this is the conventional power system framework, right? So the difference that we see in the recent days, anyone please give a brief overview or brief idea what is the change that we see from the image that is here and what we generally see nowadays? Anyone may please unmute, and it can be an interactive session so that we can have, then we have the assignments numericals, we'll discuss that, but some 2 3 slides will have discussion of basics of or initial step or the recent paradigm shift in the power system. So, like try to focus on, and so that means the integration of renewables comes into picture. So I want to give an overview of that. So anyone, if what's the basic difference that we are observing from the image shown here and the current power system scenario? Please feel free. No such things will be judged or anything like that. Trying to learn. So
Hello, sir.
yes,
On the
yes,
distribution side, we can see sources here. It is not in the conventional system.
yes. In the distribution side, the things have become bidirectional. The conventional power system, the word that I'm trying to focus is that the things were mostly unidirectional in the conventional power systems, means from generator to the customer, right? But now with the passage of time, what we are observing is that the customers means this is a two-way infrastructure from the generating side as well as the customer end. Okay, so both do participate, and we have aggregators in between who coordinates these information, and accordingly system balance is to be maintained, right? So, so I guess people are there from UG also, right? So the people, students from the UG courses, they have the module called the power flow analysis. So anybody has any idea what power means? What the UG people means who are from the UG side or going through UG courses? So, so mostly this is the main power system, that was the conventional power system, was unidirectional. But now with the IT, which OT is the operational technology and IT is the information technology. So IT and OT both combines and accordingly delivers better infrastructure. But the thing is that since we are trying to deliver more of the system where, or we are trying to uh, we may say to set up some kind of such kind of system which would be in a closed loop control, and they can interact in the form of information as well as their participation in delivering the, or to maintain the power balance, right? So what we can see in this diagram is that the present or the modern day smart grid structure, right? So this is the current framework, and each and every government, each and every country is aiming towards the future grids where more and more greener kind of means renewables are getting trying to means government is trying at least in a major scale. I have some data means in the 2025, yes, I have taken some data so that the global mix of the, we may say, the participation of installed capacity of the conventional units as well as the renewables, means all these things. I'll just show you within some time. So here we can see is that this is the modern grid with control center here at the center of the entire system, and we have electric vehicles, smart house means IoT enabled systems may be there. Okay, so that also smart meters are getting integrated nowadays. Many of you have heard the integration of smart meters. Many of your houses might also have smart meters, and the main aim is to see or to find out that the information should flow to the decision making body, means the control center, right? And based on that control center, one will deliver right amount of information, and accordingly the participants, means the customers as well as the we may say what I would like I'm trying to say is that the personnel from the areas as well as the regional load centers and all of them will interact and the load will be shifted accordingly since we are and trying to be a smarter means we are trying to make our grid much more smarter. Okay, and the main aim is to reduce the thermal plants means the carbon means not the thermal means where carbon dioxide emission is or means carbon emission is there, carbon footprints we need to reduce, right? So we are aiming with wind power, solar power. There are solar parks. The biggest solar park in India is at Rajasthan. Can anyone please name? Many of you might be from there, so many of you may know biggest solar, maybe biggest capacity, installed capacity of solar, the amount of power it can deliver. So it is, you may search, it is called Bhadla Solar Park. Here around 2.15 gigawatt of solar, with approximately 2.15 gigawatt of power can be maximum generated, but means that is the maximum installed capacity. So, and all of these things, all of these equipments aim to improve the voltage profile, to to integrate the renewables in the entire power systems. So many of the so means most of the renewables that we see means when we see a solar power plant, and solar power plant is full of inverters and converters, and these things needs to be controlled properly. And all these things have a very fast response. Switching time is very fast. So accordingly, things need to respond in the form of reactive power compensation, where voltage profile needs to be improved. So there also we see, will see means as sir will teach in the lectures, you will be seeing one by one the equipments that or the group of equipments that majorly contribute to the voltage profile improvement and why is it required, right? So so I was saying that power generation mix, right? So power generation mix here, if we say the total power generation mix, there are two categories. Means one is the installed capacity and another one is the participating capacity. Means the percentage of share that a type of generating unit is participating at an instant of time to the global demand, not the global demand, to the the country's demand. Nowadays, things are also going beyond countries. Means one country to another country connection is done to some extent, but the MOU has been signed, and accordingly, underwater cables towards the Arab countries. Uh, yes. Smart grid is the trending course. Means you need to, you can have a very good overview of the IT side as well as the OT side. Means the main aim is to means already the operation technology that is existing in the power system. People are quite aware of the of these things. Means the operating personnel that you get to see in the power grid, you may say the state power electricity companies like any of the TCL, DCL, and all these things, all the companies generating PDC. So what these people are quite good or quite equipped with the operation means OT side, means the power system side, but the smart grid has the enablers from the IT aspect also, right? So people are working more and more on the IT side to secure the power system. So you will have a better overview of how things are operating. Means now power grid is the means you have heard the name of POSOCO, right? Power System Operation Corporation. Yes. So POSOCO is a non-profit organization which is derived from Power Grid in the year I guess 2017 or 17. Yes, maybe from 17, I guess, 16, 17. So, POSOCO, you may check the year, but the main aim of my saying the name POSOCO is that the PGCIL, means Power Grid Corporation of India, now POSOCO is named as GCIL, Grid Controller of India Limited. Okay. So, GCIL, their main aim is to be a non-profit organization, because there you may see both private as well as public participation, both public and private entity participation, like the Adani Power, Reliance Power, and all these things, Azure Power. So when you get to see all these private entities as well as the NTPC, NHPC, all the big stakeholders, because these are the big names of the Navaratna or the Maharatna companies that you hear. So they are also there, and the private companies are also there. So government being a PGCL, being a entirely means a government undertaking company, it is generally thought that the means if somebody is making profit from some means power, delivering power is to main aim is to earn profit, right? They will have to pay their employees. So the thing is that POSOCO is a derived, now it is a derived company which aims to, without any biasness, they aim to involve all the private and public entities, and accordingly uniformly dispatch according to the generation capabilities available from their side. So this is entirely a decision making thing, right? So why smart grid is important means my aim of your question was that, so I won't deviate much from the question. The means my aim is to say that if when we smart grid is a generic term, okay, so it has more of you may say IT and OT perspective. So you get a broader overview how system monitoring is done, system control, operation monitoring, and accordingly closed loop stability assessment. Okay, so when you know all these things, how the things operate and how the decision is taken. So the blackout, 2012 blackout. So I think many of you have heard the 2000, and many of you have gone through this phase of 1 day blackout, of the grid blackout, right? So any idea what happened? It was on 2012, 29th or 30th I guess, 30th July. It was the blackout day. So initially in 2012, from 2013, the entire Indian grid became one grid, one nation, one frequency. But up to 2013, I guess, before November or October, so four of the northern grids, east, west, north, and northeastern, all these four grids were connected together, right? And the southern grid were isolated, means it was connected to 500 kV DC link. So okay, I'll give that answer. Right. Thank you for asking questions. So, let me just complete this small overview. Why system operation and monitoring becomes much of an importance, and that is why smart grid is evolving. So because of the IT side involvement, means the operation and control can only be done if information is fetched from the ground level. So if there is no information, so how to decide what to do? So with the now when these decision making or data is coming from the LDC level, we may say ALDC, sub LDC. ALDC is area load dispatch center. ALDC. Acha. RLDC is regional load dispatch center. Okay, and another. This is the hierarchy. Sorry, I should write it. SLDC first. ALDC, then SLDC. Area is smaller areas within a state. Then comes the priority of SLDC, State Load Dispatch Center. Then comes the priority of RLDC, means priority wise, uh, these these are on the higher side, means smaller to larger in size, I may say. So this is NLDC, National Load Dispatch Center. So this is the biggest. This is one NLDC. This is owned, means operated by POSOCO or GCIL, Grid Controller of India Limited. So NLDC is in Delhi, Katwaria Sarai. So there is this is the apex body of the decision making body, and accordingly NLDC passes on the information to RLDC. RLDC, there are 5 RLDCs in India. So east, west, north, south, and northeast. Okay, so 5 RLDCs are there, and then comes the priority of SLDC, State Load Dispatch Center. Then Area Load Dispatch Center is localized areas within the state, and you may say beyond ALDC. Sometimes people also include the term sub ALDC. So you may say see these terms sometimes, or sometimes many of the uh, books or lectures won't cover this. So this is the priority, and the point of uttering the term of 2012 blackout is that is the decision means on the 31st, again when the northeast and eastern grid isolated themselves, okay, from the western and the northern grid, and these western and northern grid have seen the already the overloading, and the one line got overloaded around 1.7 times the loading capability, and the limit violated, and accordingly the breaker tripped, and that overload uh, shifted to the next line, and in this way it was a cascading failure, and means the western grid and northern grid couldn't, means western grid, the catastrophe happened in the western grid, so but northern grid couldn't isolate, but eastern and northeastern grid isolated. But on the next day, after entire work and all these things being done, so when on the next day 31st, people tried to synchronize all these 4 grids, these all 4 grids went out. Okay, and so what I have studied is that, and came to know, I would say rather, that the decision making that would have been that was required to be done is within a time frame of 2.5 seconds or 3 seconds. That was the window, means time window, where a decision should have been made to protect the grid from these cascading failure. But that is not at all possible for any human entity, human personnel to decide and or to deliver the instruction to the grid or set the control command. So that led to the failure. So monitoring and control is the importance of monitoring and control. I'm trying to emphasize that. So that is the major aim of smart grid, grids becoming smart. Smart in the sense of OT side, but in the other sense, the scope of research and all these things have evolved with the IT getting enabled in the OT side, because the data, so cost is involved. Ultimately, we need to minimize cost, but when cost is involved, we have a limitation of how much we can invest. So the security layers, how much amount of security, the more the security layers of these equipments or data collection devices, the more would be the cost involved. So how much we can we can, means there would be a threshold that how much we can invest and how much. So sometimes if the things are not secure, these data collecting devices do face challenges of data frauds and all these things, false data injections and all these things. So research is going on. So that is the main aim of smart business. Not only the OT side, IT side is a broader spectrum, and power system engineers are trying to learn, involve the computers, a computer aided power system. There is a beautiful NPTEL course. So computer enabled power system, computer aided power system analysis, I guess, in NPTEL by Professor Vishwarup Das from IIT Roorkee. So you will get to see why the computation power system is based on computation. Things are there, but decision making has to be done and perfectly done. Otherwise, systems would go into a different side that is not aimed at all. So, and the question that you have asked, what is the major difference between existing system and of the grid and smart grid. Now the thing is that India is getting smart grid, means aiming towards smart grid, and how they are aiming. So first of all, in 2020, 16 or 7 means the project, that Indo-US project. So the project was given maybe in the 2017 or 16, and it was a project of for 5 years. Means our government had given the proposal, means open for proposal and all these things, and the project was pilot project. It was a pilot project for making the grids to be smarter, and 12 distribution companies have been allotted the project in 12 areas. Means means in for West Bengal I can say WBSE DCL, for Mumbai, Maharashtra there will be MSE DCL, means like Karnataka State DCL. So 12 DCL companies had been given, and only one academic institute was given. You may see that online also. So it was IIT Kanpur, and there in our campus we have a smart grid pilot project that was run. So our entire campus is smart grid architecture, and only academic institute, and the project was for 5 years. So the main aim of government is to see that how things will be if the interactive devices would be there in the grid, and how people would participate, because customer participation is also a must, because many of you have heard the term demand response, right? So there you need to have customer participation. So how much the customers are willing to participate, that is also required. How much the customers, because many a times we get to see that the customers are sometimes more of a political side and all these things. I won't go there. So there is a huge deficit, means ATC losses and all these things you have heard. So customers don't participate, means they don't pay much, the entire, means the bills and all these things. So nowadays there is the smart grid infrastructure would try to integrate auto disconnection and all these things, so that the customers are bound to pay, because once the customer participation is not 100%, so grid side, government side cannot deliver 100%, right? So India is working towards smart grid. In 2022 May, I guess, 2020, no, not 22, 23 May, you will have a blueprint of the entire smart grid pilot project. So IIT Kanpur, IIT Delhi, it was UISIS. The project name is UISIS. So you may search and you may see the project. This is the acronym of the entire Indo-US, US-Indo. So you may go and search. So the blueprint, that how Indian grid can become smart, around 120 pages of the entire study that has been done by the professors, industry partners, and the results IIT Kanpur, IIT Delhi, and TERI, the Engineering Research Institute. So these three institutes have participated with the end users or distribution. No, both means here for the customer, I am saying, or I am emphasizing on the end users, because distribution companies are trying to involve all these things, because these customers are the, means the loads that needs to be delivered to the loads are to be delivered to the customers, right? So distribution companies are willing to do all these things, but it is the involvement of the customers that will aid in making the our grid smarter. So I am referring to the customers as end users here at present. Okay, both commercial, residential, as well as the industrial, means customers, not only the residential, but big customers, industrial customers, commercial, everyone needs to participate, right? So so India is working on the smart grids. People are working on. You can find many research activities from the Indian perspective, as well as globally. America, UK, all they have many things which are much smarter than India, but India is also growing in a very good pace. So Okay, just a brief of in the installed capacity. So when it comes to the installed capacity of, I would say, coal. So any idea what is the installed capacity of coal? Basic in percentage of the, if 100% is the total installed capacity of coal, renewables, hydro, and all these things. Any idea what is the present installed capacity percentage? Any rough guess you may do? You may write in the chat box. You may unmute yourself. Now. Coal, then I would say
150
five.
gigawatt.
Yes.
150 gigawatt.
That is, you are saying in gigawatt, but I'm just saying in percentage, total in percentage. One total, what is the total load, in total installed, I would say the Indian load, maximum load, Indian load, any idea? Maximum means that is not the case each and every time. Loads vary, but so total of 400, I would say 484 gigawatt is the demand, and from the coal it's around 45%, I would say. It is still installed, and from the renewable side, is I would rather say solar first. Solar is the biggest participant in the form of renewable side, and nuclear is around 5%. These are more or less uh, rough values, but total fossil fuel based, I would say it has reduced beyond, means less than 50%, means 40. Recently, in a post from the government, it has reduced to 49.9, the fossil fuel base, and the renewables have gone, means Ministry of MNRE, where hydro is also a part. So total installed capacity has gone beyond 50%. Okay, but the problem or the issue is that what is the uh, participation mix? Participation mix. So when it comes to participation mix, the coal that uh, that you have seen is around 45%. 45% of the coal delivers around 74 to 75% of the load at each instant of time. Means this is the percentage share at every instant of time, average percentage share. So although the participation is maybe at a point of time the total load of India is, let's consider 280 gigawatt. So out of this 280 gigawatt, coal still delivers 74 to 75%. Okay. Although it is installed capacity is around 44-45%, but still, so the participation mix is still high for the coal. In the case of renewables, in the case of renewables, it's around 13 to 14% of the total mix. So out of 13 to 14% of the total 280 gigawatt would be delivered by the renewables at each and every instant of time. Considering means, and this 280 gigawatt, this power requirement will be varying for every 15 minutes. In India, we have 15 minutes slab. Okay, so the thing is that we still need to reduce this percent to minimize the global carbon footprint, and for that the renewables need to be integrated more and more with the power electronics applications being integrated more in the power system side. So that's a major challenge, and researchers as well as the industry experts all are working in, professors are working with various projects and all these things. So this was my aim, that still we need to work more on the power electronic side. This is the basic overview of how transmission network and distribution network. I won't go much into detail, but I'm trying to show is that this is an interconnected uh, network. Means transmission is mostly, you will say, see to be an interconnected, whereas this is mostly, you will get to see radial in nature. Okay, so this is the distribution side, where this is the main distribution. This is the HVMV substation, and from that MVLV substation, you will see the nodes connected. These are the nodes, for there are, you will get to see many distribution side feeders and all accordingly. So this is the overview of the power system side. Now coming to the course or overview. So I think professor has detailed much and derived also all the basics, how the reactive power compensation needs to be done and what needs to be done, what is the significance of active and reactive powers, and how these things needs to be uh, considered to improve the voltage profile. And in the upcoming weeks, we will get to see the implementation, or you will get to see in the transmission side applications. So I think overview of the week, if you want to give, I'll do. But if you have a good, because since sir has detailed everything and already discussing the power system side, we'll have to do the numericals or the previous assignments. So if any questions are there, or if you still want me to discuss on something of, as sir has discussed in the 2 lectures or 3 lectures, introduction, considering the introduction one, you may say and I'll do that. Otherwise, we'll switch on to the questions or numericals, basic numericals, since it is the numericals you will, as per the lectures you have seen, the numericals would be based on the power, how the power factor, based on the power factor, real and reactive power and all these things, you need to calculate and get values. So if you still want me to discuss on something, you may point it out and I'll do that. Otherwise, and you can ask questions. Otherwise, we'll switch on to the numerical side or questions, previous assignments. And all this.
I think the theory part has been covered by sir very well. We
Yes.
can proceed to the problems part.
Okay. That. So keep it an interactive one, which I'll give the important values, and accordingly, these small numericals and the values I'll put up here, and accordingly, please calculate and just please be interactive so that it feels good. So as days passes, the participants count generally reduces. So hope this semester will have more and more participants in the upcoming days also. So okay, so okay, then let's start numericals. So as we are instructed that since many of the participants are not there, means 2 of the TAs are there, right? So many of you have attended Saturday session also, might may have attended, but many of you might not have attended. So we have a previous semester question answer uh, module. So I'll first put up the questions, and for those people who would be getting common, so you may still practice, I would say, because many of the students won't coincide both the days, right? So we need to discuss those questions first. Okay. Okay. So let's start. So question one. So the question is, what are the so this is the question. So you may start, and in the meantime, I will be putting up the options. Okay. So these are the options. So I think it's clear. C. Yes, C is the right answer. C is the correct answer. So for others, you may try to solve, and I'm also solving it. 2-3 line questions. So I think the values you have noted down, right? So that I can go to the next page. So as it is given, what are the values of active and reactive power generated by source in this circuit, right? So here we have a source 180 volt RMS, and this is the impedance that is given. So first we can calculate the current. What will be the current? Current will be 31.7. So this is the current we need to get. uh, okay. So now calculate just P and Q we need to calculate, right? So we have the voltage. So what will be the real power? If RMS values are given, this is also what we are getting is the RMS values, right? So what will be the real power? It will be
VRMS, RMS, RMS cos phi.
yes, yes, yes. VI means considering these to be the RMS values. So VRMS, IRMS, cos phi, and all these values are known. So 180 and 12 and cos phi. Just calculate what will be cos phi. Cos of 31.79. So it will be 0.8499. So the value would be 1835 will be the answer. So 180, let me check once. 12 into 0.8499. So it is 1835.78. So this is the watt, means active power, and similarly we can calculate the reactive power. So it will be again into sin phi is sine of 7. So 1137.9. So these two are the answers, right? So rightly said that answer C is correct. Just underline these two. Okay, so let's move on to the next question. So the question next question is, so it is given B for which question? Okay, okay. So it is given a reactor of 100 mVar. is supplied with voltage of 98%. So this is given 98% of rated voltage, and the frequency is 90% of the rated. So find the reactive power absorbed. So this is the question. I think the question is clear, and you may start. Until then, I can write the options, possible options. So these are the possible options. So this is 100 MVAR. A reactor of 100 MVAR is supplied with voltage of 98% of rated voltage, and the frequency is 90% of the rated frequency. It's rated frequency. So find the reactive power absorbed by the reactor. Anyone, please. How is frequency related to the, I would say, frequency related to the reactive power? Considering a reactor being placed, uh, what is the frequency dependent factor that how is frequency related? So so when we say Q,
Proportion
yes,
is react directly proportional.
reactive power is directly proportional to what?
Frequency.
No, not directly, just inversely. Means directly proportional to voltage square and inversely proportional to frequency. Frequency means reactance. So, and for a reactor, you will see 2 pi FL. So here the frequency is integrated. Okay, this is the frequency. So given this equation, please try to solve. So this Q, I guess the values you have noted, right? This 100 MVA, 98% is proportional to voltage and 90 with frequency. Considering these values you have noted. So what we know is that this value is given 100 MVA. Now there is a decrement in voltage which is 98% of the rated, means this V becomes 98% of the rated, and X becomes, means in the percentage it's 90, so it's 0.9 of the previous, means already we have a Q1, so considering this to be Q2, so, or we may say Q new, considering this to be Q new, so V square upon X, this is the term. So what is the final value? Let me solve 0.98 square 106 point
106.71.
7, yes, this is the 106.711 MVR. C is correct. Sorry, MVR. So this is the answer. I guess everyone is okay. Okay. C is the answer. Okay. So moving on to the next question, kind of similar type of question. It is given load is absorbing 100 watt of active power. Watt of active power and 75 VAR of reactive power. Okay, so and these two from a source of 250 volt 50 hertz single phase supply. Single phase, you can understand single phase, right? So the question is, find the value of the capacitor to be placed across the load so that the current drawn from the source is at unity power factor. So I guess the question is clear. A load is absorbing 100 watt of active power and 75 VAR of reactive power, okay, from a source of 250 volt 50 hertz single phase supply. So find the value of the capacitor to be added to be placed across the load so that the current drawn from the source is at unity power factor. options I missed, right? Options. So you try to solve till then I write the options. So I guess you have started, right? So these are the values: real power, reactive power. This is the source side voltage, and we need to maintain unity power factor. That's the question. So value of capacitor to be placed across load so that the current drawn from the source is at unity power factor. So okay, so let's start solving. I guess the values you have noted down, and if somebody finds the answer, you may please type in the chat box, and till then we'll try to solve. Okay, together we'll try to solve. So already it is given the 75 VR is the reactive power. So this reactive power is load. This load is absorbing. Okay. So yes, yes, yes. 3.89. Correct. 3.819. Sorry. This is the correct answer. Correct. Correct. Yes. Okay. For others. Okay. Great. So for others, I'll do solve it fast. So the 75 VAR is the reactive power, load is absorbing. So somebody needs to deliver that, right? So this is the capacitor is delivering. Okay. So we may directly say that the reactive power we from the capacitor end is, as previously we have seen that V square by XC. So from here we can calculate the value of Xc since we need to find the value of capacitor. So V square, it is given 250 volt square, 250 square by Xc. Xc means Xc is on this side, so QC value is already known, 75. So what will be the value of Xc? 250 square. So it is coming as 833.33 ohm. Okay. So from here we can calculate C. So what will be C? We know that Xc is 1 by 2 pi Fc. So just place C here and 1 by 2 pi, and F is given 50 and Xc is 833.33. So plug in these values. We have plugged in the values and just calculate what will be the value. The answer would be this 3.819 as rightly said, or we can say similar to 3.82. So, any doubt? Okay, so let's move on to the next question. Okay, thank you. So these type of questions are there in assignments also, so you can practice these questions so as to have an idea of how the assignment will be. And also these type of questions will come in the exam, final exam. Okay. Type of the questions would given more or less similar, basic type questions, as well as we will move towards the end of this course, questions will definitely vary. So, but it will be the type of question more or less limited to the assignment questions discussed. As you will also get the assignment question, these are not the same assignment questions, but relatable. Okay. So, so the question is, consider a three-phase balanced system with each phase voltage as VA is 220 sine omega t volt, VB is 220 sine omega t minus 120 volt, and VC is 220 sine omega t minus 240. Okay, and the currents are also given. Directly write here voltage and currents as. So currents are IA is 10 sine omega t minus 36.86 amps. IB is 10 sine omega t minus 156.87 amps, and IC is 10 sine omega t minus 276.87 amps. So what is the calculate the total active power of this system? This is the question. So please try to solve. I am writing the options, possible options.
Option B.
Option, which one?
B. B.
B. B you are saying, right?
Yes.
B, Bombay.
Yes.
Yes, yes. Yes, option B is correct. Yes, B is correct. So I think most of you have solved, but still, this is a one-line question. So if you emphasize on the balance part, then everything becomes it will become easier. So we need to calculate the real power. So it is 1.5 Vm Im cos phi, right? So just it's 3 by 2. So this is a fixed value. So what will be the answer? 1.5 into Vm is 220 and Im is 10. Now one thing we need to check is phi. So what will be phi?
36.86.
36.86. So just plug the values and get the answer is this 2640.34. This is the correct one, correct answer. So moving on to the next question. Single phase industrial load is given as 6 megawatt. Okay. Now this is installed with shunt capacitor of rating 2 MVAR to maintain 0.9 power factor lagging. If capacitor goes out of service, what is the power factor of the industry? So the question is 6 megawatt installed with shunt capacitor of rating this one to maintain zero point 0.9 power factor lagging. Okay. Now the capacitor is out of service. So what is the current power factor or operating power factor of the factory? I think the question is clear, right? So can anyone say what will be the possible? Will it increase or decrease? Just can anyone
Decrease.
say? Yes, yes. So one thing it is clear that it will be decreasing. So all the options are also in the decreased value only, but still So if any options are given in the higher side, so we can directly eliminate. So please calculate. Okay, so you also try to solve. Till then, I guess the values you have noted down, right? So that I can start solving, and in the meantime, you can also find the right answers. So, so initial cos phi that is given is zero point 0.9, right? So we can say cos phi 1 is given as 0.9 lakh. So we can calculate from the value of cos phi 1 equals to zero point 0.9. So we can calculate phi 1, right? So what will be the value? Cos inverse. Just check. 25.84. So let's keep this value. Now 2 MVAR is the capacitor rating. So now this amount of angle for zero point 0.9 cos phi 25.84 system was operating in this angle, but with the and for that the capacitor that was installed is 2 MVAR. Now how much is the Q value for this? What is the Q value? So the Q value, so P we have, right? So P is 6 megawatt. So 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 we can see 5. So P is given as 6 and tan of 20 25.84. So directly we can calculate Q. So what we can see is that the answer is 2.91. 2.905 is the value. So 2.9 MVAR, yes. 2.9 MVAR is will be shifted. Means will be shifted by what? 2 is the shortfall and 2.5 MV, 2.91 we can say 2.91 MVAR is the shortfall if the capacitor goes out. So the new Q new will be 2.91 plus this 2 MVAR that was previously installed but now out of service. So it becomes 4.91 MVAR. So with this 4.91 MVAR and 6 megawatt is the real power that is installed. So what will be the phi 2 or phi new? Maybe we can say phi 2 or phi new. We can consider this as tan inverse Q new by P. Q new by P. So Q new is 4.91. Tan inverse 4.91 by 6. Just calculate. You will get inverse 39.29 degrees. So if we say in the form of power factor, so to get the value in the form of power factor, this is the angle. So we just need to do cos phi. So cos of 39.29, and this will give cos of 0.77. So the final answer is 0.77 lakh. So C is the correct answer. So is it clear to everyone?
Yes, clear.
Okay, okay. So moving on to the next question. Kind of similar. Okay, so again, single phase um, this is, hmm, single phase industrial load rated at 500 kVA, 0.8 power factor lagging. So this is the load is installed with synchronous condenser of 100 kilowatt. So find the power factor of the synchronous condenser to improve power factor to unity. So this is the question and these are the options. So you will please start solving kind of similar question that we solved. So means we need to find out the power factor of the synchronous condenser that will cause the improvement of power factor to unity from zero point 0.8 power factor lagging. That is in the current scenario, this zero point 0.8 power factor lagging would get improved to to unity power factor. Okay, so these are the options. I'm writing down the options. So till then you can start solving. So these are the options. Here the question is how much the synchronous condenser will improve the power factor.
0.316 leading.
0.316. Just let me check the answer.
Option C.
Option C. Okay. Option C, right? Option C, 0.316 leading. Yes, this is the
Yes.
right. Yes, this is the right answer. Okay, so okay, let's start solving, and others may please try to solve till then. So it is given that the zero point 0.8 power factor lagging. So and the kVA rating of the industry is given. So active power of the industry, we can say it is 500 into 0.8. This is the active power. Okay, and the reactive power to industry is 500 into, means general thumb rule, we can say that if it is 0.8 it will be 0.6. Okay, so you can check also, means by calculation. These are common power factors that is generally given. So it will be 300 kVAR. So to make the power factor to unity, so how much the synchronous condenser? So the synchronous condenser should uh, deliver 300 kilowatt, right? To make the power factor or to improve the power factor, the power factor to unity. Okay, so this is the option, or this is the motto or aim. So for the rating of the condenser, it is given E con, I should write E con is given 100 kilowatt, and kVAR required is Q con, we can say, is required to be delivered. So is for the industry value 300 kVAR. So this Q condenser should deliver this Q industry. Sorry, QIND is industry. Okay, so IND is not inductance; it is industry. Just subscript I have chosen randomly, nothing else. So this much amount should be delivered. So we can find out the power factor phi, that is tan inverse of Q by P, Q con by P con. So what will be the value? 3, tan inverse of 3, tan inverse 3, and this will be 71.56, 71.56 degree leading. So now this is the power factor. So power factor is cos of 71.56. So this will give point. This is the answer, 0.316 leading. So as rightly pointed out or rightly calculated, this is the answer. Okay, I guess this is clear.
Yes, sir.
Okay, so so question. So here three different customers are given, right? Three different customers are given. So 180 volt for all and 9 ohm, 9 ohm, 9 ohm. Okay, but there is a change in power factor. Here the power factor is 0.82. This one is power factor 0.75, and this one power factor point sorry 1 unity. Okay, so current I1, I2, and I3. So these are the three circuits: circuit 1, circuit 2, and circuit 3. So these are three customers. So the question is, which customer which customer will generate least revenue for the utility? This is the question, considering or assuming electricity will being generated from, or sorry, generated based on energy consumption. Okay, so A is circuit 1, B is circuit 2, C is circuit 3, and D is same revenue for all.
Option B.
Option B. Okay. Yes, option B is correct. Yes, option B is correct. So anyone needs clarification for this so that we can move on to some questions more, because you can clearly understand what is the issue here. If anybody needs clarification, I'll okay. Let's do it fast. For okay, okay. Some might later on questions may arise. Just let's do it fast. Okay. So I1 for, so let's circuit 1. circuit 1. Let's do it for circuit 1 and accordingly we'll do it fast. So circuit 1, what we can see is that voltage is 180. So what will be current? Just say it fast so that current will be 20 amperes, right? 180 divided by 9. This is the current. So 20 amperes is the current. So and energy is based on the VI cos phi. So V is given 180, means the real power consumption. So 180 into 20 into cos phi is 1. For circuit 2, what will be the current? I2 is, current is same, but there is a phase shift in the angle, right? There is a phase shift in the angle. So we need to, for 0.75, what will be the angle? Can anyone please do it fast? Magnitude will be 20, but there is an angle displacement. Since it is, power factor is lagging. Anybody calculating? Or okay, let's.
41.4.
Okay, then this will be minus 41.4. The current will lag. Okay, so accordingly the power factor, which real power consumption uh, will be 180 into 20 angle minus 41. Okay, let's do it in this way. Excuse me. 8 into 20 cos 41.4. So if you calculate it, some values will be, it will be something less, means for this it is 3.6 kilowatt. So considering energy billing, it's for 1 hour it will be, energy will be kilowatt hour. So this is the 3.6 unit, but here in this case it will be 2.7 kilowatt, or for energy we may say energy 2 is kilowatt hour. Okay, and for circuit 3 it will be kind of similar only, because the power factor is 82.82. I3 magnitude will be 20, but angle will be something. Is anybody calculating? Otherwise, it's 180 into 20 cos. Uh,
33.9.
okay, thank you. 33.9. So this will be 33.9, and accordingly, if we multiply cos 33.9, it will be 2.988. 2 point energy 3 will be 2.988. So what we can observe is that this customer is generating less energy consumption and will generate less revenue. Okay, rightly pointed out by everyone. Thank you. So moving on to the next few questions. So these are simple questions. You can do it in one go. Kind of similar. So factory draws 300 kilowatt at zero point 0.6 power factor lagging, and find the bank capacitor bank required to improve power factor to 0.95 lakh. So please calculate. Options. Yes, B is the correct answer. So easy question. So okay, so let's solve. Okay, so for others, you may please find the answer. So we can see phi 1. Phi 1, what will be the value? Cos inverse 0.6. Cos inverse 0.6 will be 53.13. Okay. So Q1, which was initially being delivered, is P10 phi 1. So P10 phi 1 is 300 into 10 phi 1, 1.33. I'm directly writing the answer here. 300 39 point 399.99 means around 400 kW, and now phi 2 is required power factor is 0.95. So 5 8 So Q2 will be 300, 10, 18.19. It's 98.57. 58. So, so from these two, what we can observe is the amount of compensation required Q1 minus Q2. So it is 301.2 or 3. Option was 2, 3. Okay, it's 301.3. So I think it's clear, right? So these are the, oh, okay, kind of similar question. Both are nearly similar question. Okay, let's solve this one. This will sum up the session, today's session. So kind of similar. A load draws 100 kilowatt at 0.7 lagging power factor. So find the reactive power before and the compensation needed to improve power factor to 0.9 lagging. Kind of similar question. Please solve it first, then we can. Okay. Options. C. C is the answer. Yes, C is the correct answer. Rightly pointed out. Okay, so same type of question. So phi 1 is cos inverse 0.7. So cos inverse 0.7, 45.57. So Q1 will be 100, 10, 45.57, and this is equivalent to 100. Now phi 2 is cos inverse 0.9, and this would be 25.84 degrees. So Q2 will be 100, 10, 25.84, and this is 100, 48.42 is 48.42, 48 kW. So compensation needed is additional compensation which is required is Q1 minus Q2. It is 51.7 kW. So it's nearly this answer is nearly matching. So option C is correct. Okay. So that's it from my side. And if you have any questions, you may ask. These are the some of the questions of the previous sessions, means previous semester or previous years, and you will get to see similar type of questions in the assignments. And I will upload this and share it in the portal. So I'll share the link with the committee, means the course coordinators, and they will surely upload in the your portal, means NPTEL SWAM portal. So you will get to see the problem solving. You'll get a tab problem solving session and something like that. There you can access this PDF, and the video also. The video link will be given to you, so you can access everything. Okay. So it will take maybe 1 or 2 days, because I'll share with them by today or tomorrow, and you will get to see within 1 or 2 days. After they give the access to you. Okay. So that's it from my side. So if you have any more questions, you may ask. Otherwise, we can end today's session, and we will meet on the next Tuesday, 6 to 8.
Yeah, thank you.
Okay. Thank you very much. Thank you.